Why was this shape over here similar and this shape not similar? How do we show that mathematically? What are you talking about where this one on the bottom is similar, but this one on the top left, they are not similar? I'll pause the thing so that I can get some answers from you, and then I'll repeat what you say. Okay, wait, someone's already throwing it out. Okay, wait. Someone says because it is the same blocks in the bottom one. All right, Ivalani's saying is it was exactly half of for the measurements. I think I see where you're going with that. It's not the same size or shape. You're talking about the top left one, Dawson. All right. Yes, you're right, Justice, that the top left is not congruent, nor is it similar. But I'm asking, what I'm really trying to see is why. Um, Here's, I think, what Ivalani meant. Do you folks see how this T on the bottom, it almost looks like a Tetris piece. Of course, you folks don't even know what Tetris is because you're probably that young. But see this piece on the bottom, it looks like a Tetris piece. And the piece over, like, above it looks like a Tetris piece that's like twice as big exactly. Do you see what I mean? Like, see the bottom length of this thing? It measured 1 units long. Is that correct? Now, the bottom of this bigger T measures 2 units. And in fact, everywhere where this thing measured 1 unit, this thing measured 2 units. Does that make sense? Okay, okay. So it's almost like I just, doubled its size. Yeah, that's exactly all right. So Evelyn is saying that's what I meant. And that's exactly what I'm getting at. Is that all right? Let me ask you a different idea. What we're going to do is we're going to compare what we call ratios. Ratios are fractions. Let me pull up a paint document so I can start drawing on this thing. All right. What I mean by that is this. If I were to take, okay, wait. Here's one of my T's. Not as nice as theirs, sorry. If I were to take any piece of this thing, like say this side right here, 2, and then the other T looks like this, right? Let's label the distances here, and I'll do that in a different color. Color be dark red. All right, so this is 2, 2, 2, 2, 2, 2, 2, and counting across, I get 6. And this is 1, 1, 1, 1, 1, 1, 1, and counting across, I get 3. Now, what I mean by a ratio is usually when you hear the word ratio, you think fraction. That's what you should think. So if I were to take, say, this left side right here, and this left side right here, and I were to divide the both sides by each other, I were to say, okay, what is 2 divided by 1? What does that equal to? 2. Okay. Now, I were to take corresponding sides. That means the same sides. For example, let's take the top now. Let's look at the top, and we'll use a different color for that. The top. I got 6, and I got 3. So what is 6 divided by 3? It's also 2. In fact, if you divide anything on top here by its corresponding side, so what I mean by corresponding side is like this. This right here, the corresponding side would be this guy right here. 2 divided by 1, you'll get 2. 6 divided by 3, you'll get 2. 2 divided by 1, you'll get 2. If you divide any of the corresponding sides, the ratios need to be the same. Does that make sense? The fractions need to end up being the same.